Our next step in this process is to talk about molecular formula. Now, I left the definition for empirical formula up here. Smallest whole number ratio of atoms in a compound. Molecular formula is different. It is the chemical formula as the compound exists in nature. And again, our quintessential example on this is benzene. So benzene is the empirical formula. Smallest whole number ratio H and C each have 1. Now, benzene in nature is actually C6H6. That's how it exists in nature. We want to find this for molecular formula. How does that compound exist in nature? How many atoms are there? So I have our steps written out. Number 1, find the empirical formula. So I'm actually using isoprene from the last video for empirical formula. Isoprene, we determined the empirical formula is C5H8. Now, second step in this, after we've done all that empirical formula, is to determine the molar mass of the empirical formula. Now, this has a special name, and honestly, I don't know where the name came from. If you know, shoot it in my comments. It's called formula weight, and notice I abbreviated it FW. I did write it down here for you. Formula weight is our technical term for the molar mass of the empirical formula. So I found the molar mass of the empirical formula. So it's 68.13, and that's the formula weight. Molar mass of the empirical formula. Now what we're going to do is simply divide the molecular weight by the formula weight. Now the molecular weight, really important. This has to be given to you. It comes from mass spectrometry. There's going to be a spectra that determines the mass of that compound as it exists in nature. So this will be given. Now in this particular problem, the mass spec gave us that the molar mass of the compound is 68.13. Actually, the mass spec said, let me look, I think it was 68.14. Oh, 0.11. That's what mass spec gave us, 68.11 grams per mole. That will be given. So if you're given asked to find empirical formula, molecular formula, and they give you a molar mass, they will be giving you the molecular formula, okay? Now what we do is we just divide molecular weight by formula weight, and here's the reason why. This is the mass that exists in nature. The formula weight is just the smallest whole number ratio. So we're really trying to see how many of those formula weights fit into the molecular formula, in essence. So let's go ahead and divide it. We are going to have molecular weight divided by formula weight will be 68.13 divided by 68.11. In essence, this will round to 1. This is a special situation. Notice the last step. Multiply the subscripts by the factor. So if I take the subscripts of isoprene, multiply by a factor of 1, the molecular formula is the same. If you ever get a factor of 1, it simply means that the molecular formula is identical to the empirical formula. So we're done. This right here is both the empirical formula and the molecular formula. When I multiply by that factor of 1, it's the same thing. Now, just for sake of argument, let's say that the molecular weight had been, what, 136.26, okay? So we divide it, you come up with 2. In that case, multiply the subscripts, we would have had C10H16. That would have been the molecular formula. If we had had twice the amount of molar mass for molecular formula, gotten a factor of 2. Multiply subscripts. In this case, though, they're the same. So there we have it, C5H8. Thank you. Good work.